This video is for Chemistry in the Earth System, Unit 3.4, Lewis Structures and Molecular Geometry. Today's essential question is, what causes the three types of intermolecular forces, and what are their relative strengths? First main idea, dipoles. A covalent bond causes the more electronegative atom to have a partial negative charge, and the other atom to have a partial positive charge. These partial charges are less than the charge on an electron or a proton. This charge separation is called a dipole. If each polar molecule has two atoms, there will be attractive forces between the molecules. These dipole-dipole forces are of moderate strength. And as we will see later, a molecule with more than two atoms may or may not have an overall dipole, depending on its geometry. In a covalent bond, a highly electronegative atom pulls the shared electrons toward itself, forming a dipole. A dipole exists in HCl, hydrogen chloride, as chlorine is more electronegative than hydrogen. Intermolecular forces, or IMFs. Intermolecular forces are forces of attraction between separate molecules. There are three main types of intermolecular forces. We have the partial negative charge on an atom, and a polar covalent molecule causes it to be attracted toward atoms with a partial positive charge on the other molecules. These are known as dipole-dipole forces. We also have hydrogen atoms with a partial positive charge being attracted to highly electronegative atoms such as oxygen and nitrogen on other molecules. This is the strongest of the intermolecular forces and is called hydrogen bonding. And because electrons are always on the move, at any particular instant they may be unevenly distributed. This causes an instantaneous dipole, which create very weak attractions between molecules. These are known as London dispersion forces and are the weakest intermolecular force. These forces can arise even in a completely nonpolar molecule. The electron configurations of elements and their positions on the periodic table can be used to predict the shapes of the molecules they form, and in turn, molecular shape can be used to predict the strengths of intermolecular forces. That same information can then be used to predict some of the physical properties of these compounds. Those molecules that have shapes conducive to the formation of strong intermolecular forces will have higher melting and boiling points than those that do not. This is because more energy is required to overcome the intermolecular forces that hold the molecules together. A general rule for compounds with similar molecular masses, meaning the same weight, is therefore that the stronger the intermolecular forces, the higher the melting and boiling points. Water exemplifies the effect of intermolecular forces on melting and boiling points. The hydrogen bonding that is present between polar water molecules accounts for water's relatively high melting and boiling points. Other compounds of similar size are usually gases at room temperature. Intermolecular forces also impact the solubilities of substances in water. This is because water has polar molecules that readily attract the molecules of other polar molecules. Remember, intermolecular forces are forces between molecules. They include dipole-dipole interactions, hydrogen bonding, and London dispersion forces. At this point, you should be able to generate a full and appropriate response to today's essential question. What causes the three types of intermolecular forces, and what are their relative strengths?